Dear all, now I am going to explain the power division and isolation of microstrip power divider. So the aim of this experiment is to determine the power division and isolation characteristics of microstrip power divider, and the objective is to understand the power division and isolation characteristics of microstrip power divider. So here in this experiment, so we are going to explain the how the power division takes place over here. Okay, so and next the apparatus required here is the microwave signal generator with modulation range from 2.123 gigahertz to 3 dB, 3 gigahertz, and attenuator pad of 3 dB, coaxial detector of 2 to 3 gigahertz, and matched loads of 50 ohm VSWR meter. Microstrip power divider is how it looks over here. Okay, so this is what the setup you can see over here. So this power divider has connecting tables with the setup where we can develop a power division over here, and it has a 3 ports, one input port and 2 output ports. Okay, so with these the function of the power division network is to divide the input power into power two more power outputs as equal split. Okay, and the power divides equally. So whenever the power incidents on the port 1, it will get divided equally between two ports 2 and 3. So here also you can observe that the division of one equal amplitude in phase signals is fed to the port 2, and the port 3, the device acts as a power combiner, and the entire power appears at the port 1. That is the reverse process what you can observe here. If the power is fed only at the port 2 or port 3, then half of the power goes to the port 1 and the other half gets dissipated in the isolation resistor in all the cases. And port 2 and port 3 are mutually isolated and the procedure of the experiment is to assemble the setup as shown here and measure the reference power level by connecting the cable ends and at P and Q directly. Okay, and we have to set the frequency of the source at 0.2 to 3 gigahertz and increase the RF power and measure the output at the VSWR meter till it shows the readings ranging to 45 dB, and to increase the frequency of the source in steps of 0.1 gigahertz from 2 to 2.8 gigahertz or 3 gigahertz. So we have to note down the corresponding reading in the VSWR meter to measure the power division property of this power divider, and we have to insert the power divider between the P and Q with port 1 as input port and port 2 as which acts as an output port connected to the port Q. Okay, and we have to terminate the port 3 of this power. So with the port 3 has to be connected to the matched load of 50 ohms, and we have to read the readings from the VSWR meter for different values of the frequencies. And now we have to interchange the connection at port 2 and 3, that is we have to connect the port 3 to Q and port 2 to 50 ohm matched load and record the readings of the VSWR meter by varying the frequencies from 2.2 to 3 gigahertz, and using the calibration graph have to get the corrected values, and we have to record it as an P dash and the Q dash, and the power division from port 1 to port 2 can be calculated as the P dash minus P2 dash from the power division. And Same thing has to be repeated from port 1 to port 3, which is calculated as P1 dash minus P3 dash to measure the isolation. Measure the isolation, and now remove the power divider from the setup and insert the power divider between the P and Q with 2 as the input port, and connect that to a port P, and port 3 as output port, connect it to the Q. Terminate the port 1 using a matched load with a matched load 50 ohms, and read the recordings of the VSWR meter for the frequencies varying from 2.2 to 3 gigahertz using the calibration graph. Get the corrected values of the P1 dash and P3 dash, and the isolation is calculated in the dB. So this is how we have to tabulate in the tabular column as shown over here. So we have to calculate the P1, P2, P3, P1 dash, P2 dash, P3 dash, and whatever the for different values of the frequencies from 2.1 to 2.8, and from which you can calculate the power division from port 1 and 2 as P11 dash minus P2 dash, and also the power division from port 1 to port 3, that is from P1 dash to P3 dash. And also you can also calculate the VSWR meter readings over here. So for the frequencies, and that is for the isolation also. In the same way, here we have to calculate the P2, P3, and also the P2 dash and P3 dash, from which we can calculate the isolation characteristics by taking the P2 minus P3 dash, P2 dash minus P3 dash. Okay, so this is how we calculate the isolation. So from the tabulator columns, so we can find out the power division from port 1 to port 3, power division from port 1 to port 2, also the isolation when the port 1 is been matched to an load. So now let us look at the experimental setup over here now. Okay, so now, so this is the demo of the experiment. So here you can see that the power division can be done here. Power division can be done here by connecting this power divider to an input port to an power signal and an output port to an VSWR meter. So now, so here the port 1 is been connected to the signal 1, and the port 3 is been terminated with the matched load, and 2 is been connected to an VSWR meter. So here, as we move on to the calculating the power division, so what we have to do here is that we have to change the frequency range from 2 to 3 gigahertz. Okay, and next we have to take the readings at the VSWR. See, so this is how. So we have to switch on it, and we have to vary the RF. Okay, and by varying the RF and signal source from 2 to 3 gigahertz. So now we see the change. So we have to note down the readings in the tabular column according to the different frequencies whatever we have over here. Okay, slowly we have to do it. So we have to observe that there is a deviation at a particular frequencies. So for different particular frequencies, the VSWR readings changes over here. Okay, so this is how. So now this is the case when the input power is been connected to an port 1 and output is connected to an port 2. So now we have to switch it. So port 2 can be port 2, the output is been connected to the port 2, and this one is been connected to an, that is that load can be connected to an port 2. Okay, and the same what are the readings we have taken here, we have to, for the corresponding values we have to take the corrected values, and these corrected values are been tabulated, from which we can calculate the isolation as well as the power division for the given power.